Some foods make people curious because of their flavor, but some hold the viewer's gaze simply because of the way they are made. Instant noodles with palm weevil larvae are one of those journeys. They do not begin on a cold, gleaming conveyor belt or inside a sealed processing room. They begin deep inside the damp darkness of a coconut trunk, where the larvae grow quietly among wood fibers and decaying core tissue. From that starting point, the raw ingredient is pulled straight into a world of circulating clean water, stainless steel, inspection conveyors, sterilizing heat, and production standards that leave no room for error. What makes this process so captivating is not just the unusual ingredient itself. What truly pulls the audience in is the moment nature is forced into the absolute discipline of modern food manufacturing. Each stage feels like another layer of randomness being stripped away, making the ingredient cleaner, more stable, more uniform, and ready for mass production. Before it can enter the later stages, everything must first pass through the first gate: harvesting and raw material preparation. Everything begins with manual harvesting. Palm weevil larvae are found inside coconut trunks or palm trunks, where the soft inner core creates an ideal environment for them to grow. Because they are hidden deep inside the trunk, the extraction process cannot be careless. Workers must peel back the fibrous layers, open the right section of the trunk, and remove each intact larva one by one. A single rough movement can crush the ingredient or add more contamination. Once removed, the fresh larvae must be transferred quickly to the preparation area. At this stage, time is a critical factor. The longer the raw material remains exposed to the environment, the greater the risk of changes in smell, color, and overall sensory quality. That is why, in modern manufacturing, speed at the beginning is not just about productivity. It is the first layer of quality protection. The next stage is cleaning. The larvae are washed thoroughly with clean water to remove dirt, wood fragments, and any impurities left from harvesting. This is the moment the ingredient leaves the natural environment and enters the first controlled standard of the factory. From this point on, everything begins to be regulated. After washing, the larvae are spread evenly across a conveyor belt for manual inspection. Under strong lighting, workers examine each batch and remove any larvae that are too small, damaged, discolored, or inconsistent in size. This sorting step determines the quality of the entire production line that follows. A system is only truly modern when it knows how to reject substandard material from the very beginning. And right here, from a mass of fresh larvae just taken from the coconut trunk, only the ones that meet the required standard are allowed to move forward into the thermal processing stages waiting ahead. Once the selected larvae leave the inspection line, the process enters a controlled phase. This is where the raw ingredient stops behaving like something taken from nature and begins to submit to industrial food processing. The first stage is thermal treatment. The larvae are fed into a steam system designed to sterilize and partially cook them. Inside this enclosed environment, moisture, heat, and pressure are balanced to reduce microbial risk while preserving structure. This is one of the important turning points in the process. Before this moment, the larvae are highly perishable. Their texture is soft, their biological activity is active, and their condition can change quickly. But once the steam treatment begins, everything changes. Heat penetrates the surface, then the interior. The ingredient is no longer simply being cleaned. It is being stabilized. It is being forced into a safer state, one that can survive the industrial stages that come next. Visually, this stage has enormous power. The conveyor disappears into a chamber of vapor. Steam rolls across walls. The raw ingredient enters one side with the softness of something harvested and emerges on the other side firmer, cleaner, and more uniform. It feels less like cooking and more like a controlled conversion. Nature is not being guided here. It is being disciplined by temperature. After partial cooking and sterilization, the larvae move into industrial drying. This is where the process becomes dramatic. If the steam stage is about control, the drying stage is about extraction. Moisture has to be driven out with precision. Too little drying, and the ingredient remains unstable. Too much, and the structure can become damaged in ways that affect flavor and performance later in the noodle process. Inside the drying system, heated air circulates continuously around the product. Depending on the factory design, the larvae may travel on layered trays, mesh conveyors, or enclosed drying tunnels that maintain a thermal environment. The goal is to reduce moisture to a target level that allows crispness, longer shelf stability, and consistent grinding performance. This stage delivers one of the strongest visual contrasts in the line. Earlier, the ingredient was soft, living, and unpredictable. Now it is gradually becoming light, brittle, and mechanically manageable. Each minute in the dryer strips away more of the original instability. What leaves the chamber is no longer a fragile natural material. It is a prepared industrial ingredient waiting for its final transformation. That final transformation happens in the grinding stage. Once the dried larvae reach the required condition, they are transferred into a milling system that breaks them down into fine powder for blending. This is not just size reduction. This is the moment the original form disappears. The ingredient loses its recognizable shape and becomes a standardized food material that can be measured, stored, blended, and repeated with precision. High-speed grinders crush the crisp, dried larvae into smaller particles. Then screening systems separate coarse fragments from the fine usable powder. The finer the consistency, the more reliable the blending behavior will be in later steps. This matters enormously. Powder can be dosed accurately. Powder can spread evenly through flour. Powder can carry flavor across thousands of identical noodle cakes without depending on the shape or size of a whole larva. This is the real industrial rebirth of the ingredient. It began as a hidden organism inside a coconut trunk. Now it exists as a controlled, dry, sifted powder stored for the next stage of production. The wild origin is gone. In its place stands something modern, measurable, and ready to enter the machinery that will turn it into instant noodles. the palm weevil powder prepared, the production line shifts into a more familiar industrial language, noodle manufacturing. But this is also where the process becomes visually addictive. The unusual ingredient is no longer treated as a separate raw material. It is now absorbed into a mechanical system that transforms powder, water, heat, pressure, and motion into a uniform noodle cake. The first stage is mixing. Palm weevil powder is combined with wheat flour, water, salt, and selected seasonings inside a large industrial mixer. Heavy blades rotate through the chamber, folding, breaking, and pressing the ingredients together until the mixture becomes a consistent dough mass. This is not a gentle kitchen mix. It is a controlled mechanical collision between dry particles and moisture, designed to create repeatable structure on a factory scale. Accuracy here is critical. If water is too low, the dough stays crumbly and difficult to sheet. If moisture is too high, it becomes sticky and unstable as it moves through rollers. The palm weevil powder ratio must also be tightly controlled. It has to contribute flavor and identity without weakening the behavior of the wheat-based dough. Once the dough reaches the target condition, it moves into the sheeting system. This is where the line starts to look hypnotic. Heavy rollers compress the rough dough into broad sheets, then pass it through additional roller sets that gradually reduce thickness and improve smoothness. Each pass tightens control. Each roller pair pushes the material closer to uniformity. What entered as a coarse blended mass now begins to resemble a continuous edible sheet, smooth, elastic, and controlled. The transformation is direct and visually satisfying. The dough is not just moving. It is being flattened, refined, aligned, and standardized by steel surfaces that never lose rhythm. Every deviation in thickness matters. It affects texture, cooking performance, and the integrity of the final noodle cake. Precision here is structural. After sheeting, the dough enters the cutting section. Sharp cutting rolls slice the sheet into long, even strands, instantly turning one flat surface into hundreds of parallel noodles. Then comes one of the defining visual moments of the entire line, the formation of the classic noodle wave. The strands are guided through shaping components that create the familiar curl, giving the product its recognizable form while also helping with spacing, volume, steaming behavior, and later rehydration. At this point, the product finally looks like instant noodles, but it is still fragile. The shape exists, yet the structure is not fully locked. That happens in the steaming stage. The formed noodles pass through a steam chamber where heat penetrates the strands and sets the starch and protein network more firmly. This is the step that transforms shaped dough into a cooked noodle structure capable of surviving the drying stage that follows. Once steamed, the noodles are portioned and guided into molds that define the final noodle cake. Then the line splits into two finishing paths. One is frying. In this route, the noodle blocks enter hot oil, where moisture escapes rapidly and the structure becomes firm, porous, and highly responsive to boiling water later. The other is non-fried drying, where controlled hot air removes moisture more gradually to create a stable noodle cake with a different texture. In both cases, the objective is the same: build a rigid, shelf-stable noodle block that can travel, store, and rehydrate with consistency. Here, the line reaches full industrial momentum. Steam, rollers, cutters, molds, oil, or drying air all work as one coordinated system. What began as powder from a hidden larva inside a coconut trunk has now become a precise noodle structure, shaped by engineering and ready for the final packaging stage. Once the noodle cakes have been fried or dried and cooled to a stable condition, the process enters its final phase. This is where the entire production line accelerates into its most precise and visually relentless rhythm. The product is no longer being transformed in composition. It is now being assembled, sealed, verified, and prepared for distribution at industrial speed. The first step is seasoning integration. As each noodle cake moves forward on the conveyor, automated systems place the required sachets into position with strict timing. These may include soup powder, flavored oil, seasoning granules, or, in premium variations, dried whole larvae used as a visible topping component. Every packet must match the product specification exactly. A single missing sachet turns a finished unit into a rejected one. This stage is deceptively intense. The line appears simple from a distance, but every motion is synchronized to fractions of a second. Noodle cakes advance in exact spacing. Sachets drop with calculated timing. Mechanical guides align the contents before the packaging film closes around them. Nothing is improvised. Every movement is locked to the speed of the system. Next comes primary packaging. Printed plastic film is drawn through the machine, shaped around the noodle cake and seasoning sachets, then sealed with heat and pressure. The package is closed, cut, and released in a continuous sequence. At this moment, the product finally becomes what the consumer will recognize: a complete retail pack, branded, sealed, portable, and shelf-ready. This is one of the most visually satisfying sections in the entire factory. The repetition is almost hypnotic. A noodle block arrives. Seasoning packets fall into place. Film wraps around the product. The sealing jaws close. A finished pack shoots forward, immediately followed by the next. The speed is high, but the line cannot afford chaos. Packaging is not just presentation. It is barrier protection, identity, traceability, and shelf-life security. After sealing, each pack moves into final inspection. Depending on the factory, this may include weight checks, seal verification, metal detection, or visual inspection systems that identify damaged or incomplete units. Only approved packs continue. Rejected items are removed automatically, so the outbound flow remains consistent. Approved packages are then grouped and transferred into the cartoning section. Here, robotic arms or automated push systems load multiple noodle packs into corrugated boxes with remarkable speed and accuracy. The cartons are sealed, coated, and moved toward palletizing, where they are stacked for storage and shipment. This final stretch reveals the full logic of modern food manufacturing. What began inside the damp darkness of a coconut trunk now leaves the factory as a stable, standardized product moving through steel, sensors, heat, and robotics. The transformation is complete. The raw unpredictability of nature has been converted into a repeatable packaged food system, ready to travel from the production floor to warehouses, trucks, stores, and finally into the hands of the consumer. Once the cartons are sealed, the product enters its last industrial movement. The noodle packs are no longer individual retail items. They now become cargo. This is the stage where food manufacturing stops looking like preparation and starts looking like logistics power. Every carton is transferred, aligned, stacked, and prepared for movement at scale. Automated palletizing systems take over. Mechanical arms lift cartons in repeating patterns and place them onto pallets with exact spacing and balance. Each layer must be stable. Each stack must match the shipping format. This is not just about neat arrangement. It is about protecting the product during transport, maximizing storage efficiency, and keeping the distribution flow uninterrupted. Visually, this stage has a different kind of intensity. Earlier sections of the line were about steam, oil, powder, and motion. Here, the drama comes from order. Box after box rises into tall geometric stacks. Plastic stretch film wraps around the pallet, locking the load into a single transport unit. The product has completed its transformation from raw biological material into organized industrial volume. From there, the pallets move into warehouse staging. Forklifts or automated guided vehicles carry them into storage lanes, where they wait for dispatch according to batch schedules and delivery plans. At this point, traceability becomes as important as packaging. Every lot, code, and production timestamp matters. A modern line does not simply make food. It creates a trackable system where every finished unit can be identified, counted, routed, and monitored. This final stage may seem quieter than grinding, steaming, or frying, but it carries a different kind of power. It proves that the process is complete. The ingredient that once existed hidden inside a coconut trunk has passed through washing, sorting, heat treatment, drying, milling, dough formation, noodle structuring, seasoning insertion, sealing, inspection, cartoning, and now distribution control. Nothing about it is random anymore. That is the real spectacle of this production line. The most impressive transformation is not only physical, it is systemic. A raw ingredient from a humid, unstable natural environment has been absorbed into a chain of steel, heat, timing, sanitation, and logistics until it becomes part of a repeatable commercial food network. And that is what makes this process so satisfying to watch. It begins with something organic, fragile, and unpredictable. It ends with something engineered, stable, and ready for mass circulation. The viewer is not only watching food being made. The viewer is watching uncertainty being crushed into precision. From the dark core of a palm trunk to the bright speed of a fully automated factory, instant noodles with palm weevil larvae represent more than an unusual product. They show how modern manufacturing takes a material that seems impossible to standardize and forces it into exact form, exact rhythm, and exact scale. This is the final image the line leaves behind. Not just a packet of noodles, but the victory of industrial order over raw natural chaos. At the end of this journey, what remains in the viewer's mind is not just the product. It is the scale of the transformation. What began as a soft, living ingredient hidden in the wet interior of a palm trunk has passed through washing, sorting, steam, drying, grinding, mixing, rolling, cutting, steaming again, frying or air drying, sealing, boxing, palletizing, and dispatch. Every stage stripped away randomness. Every machine removed another layer of instability. Every transfer point pushed the material further from its origin and deeper into industrial precision. That is why this process feels so satisfying to watch. It is not simply food production. It is a conversion of environments. The ingredient begins in darkness, moisture, wood fiber, and biological uncertainty. It ends in bright factory light, stainless steel, controlled airflow, coded packaging, and synchronized logistics. The contrast is so extreme that the final product feels almost unreal when compared to its starting point. And that contrast is the true spectacle. Many production lines are impressive because they are fast. This one is impressive because it forces two opposite worlds to collide. On one side is an organic material shaped by nature. On the other side is a rigid industrial system built on timing, hygiene, pressure, heat, motion, and repetition. The fascination comes from watching which side wins. And by the end of the line, the answer is clear. Industry wins completely. The larvae are no longer visible as living organisms. Their original form has been broken down, stabilized, converted, blended, structured, packaged, and scaled. What survives is not the raw ingredient itself, but its engineered function inside the final product. Flavor becomes controlled. Texture becomes repeatable. Appearance becomes standardized. Shelf life becomes manageable. Distribution becomes possible. This is what modern manufacturing does at its most powerful. It does not merely process raw material. It reorganizes it into a system. There is also something strangely cinematic about the final image. A finished pack of instant noodles looks small, light, and ordinary. But behind that simple package stands an entire chain of industrial force. Water systems cleaned the raw input. Steam chambers sterilized it. Drying tunnels pulled moisture away. Milling systems reduced it to powder. Rollers and cutters reshaped it into noodles. Heat fixed the structure. Automation sealed the result. Robots stacked the cartons. Logistics carried it outward. The package may look simple, but the process behind it is anything but simple. That is why a production line like this holds attention so strongly. It moves the viewer through several emotional layers without stopping. First comes curiosity, because the ingredient is unexpected. Then surprise, because the process is much more advanced than people assume. Then tension, because heat, speed, and machinery take over. Then satisfaction, because every chaotic raw element is organized into perfect flow. By the end, the viewer is no longer thinking about a strange ingredient. The viewer is thinking about precision, control, and scale. And that is the final reveal of instant noodles with palm weevil larvae. This is not just a specialty product. It is a demonstration of how modern food engineering can take something unusual, difficult, and unstable, then force it through a chain of exact operations until it becomes a repeatable consumer product ready for mass circulation. From the hidden softness of the palm trunk to the sharp rhythm of the packaging line, this entire process is a story of industrial domination over raw natural disorder. It is fast, it is controlled, it is visually relentless, and above all, it is proof that modern manufacturing can turn even the most unexpected ingredient into a product built for speed, consistency, and scale. So the next time you see a single pack of instant noodles on a shelf, remember this. Inside that light package is an entire world of heat, pressure, steel, timing, and transformation. If you want more factory journeys like this one, more extreme food engineering, and more modern production lines turned into cinematic stories, make sure to like this video, subscribe to the channel, and turn on notifications so you do not miss the next process breakdown. Because behind every ordinary product, there is usually an extraordinary machine waiting to be revealed.